So your first one, so write it in imaginary form. Remember, that's just that problem that you have a negative under the root bar. So in math 1, that's when you go, oh, I can't solve it, and walk away from it. Now we are using our I, which allows us to to actually come up with an answer. And then so you're thinking I and the square root of 16, and the square root of 16 is going to be 4. So it's going to be 4I is your answer. And remember, when you're taking the square root of anything, that's asking what number are you multiplying by itself 2 times. So 4 times 4, that's going to give you 16 in this case, or whatever number's underneath your root bar. And just for a conversation that I was having with some students in another class, if it's a cube root, so to like a 3 or to a 4th root, it's asking the same question, but that 4 would happen 3 times or would happen 4 times. So just to put that in the back of your brain for future styles of questions. So it should be 4I for that one. I-33. This is where you divide by 4. If you divide that number by 4, whatever your leftovers are, that'll help you a little bit. So 33 divided by 4 will be 32, and there will be a leftover of 1. So I to the 1, so that's just I. And I is -1. So I'll say that one time. So whatever this number is, if it's big and ugly, divide by 4. And then whatever is left over, the remainder is what you then can use, because hopefully you remember from the table, there's 4. It's I to the -1, I to the 1, and negative I believe, if I'm not mistaken. Number 3 says simplifying the radical. So if you remember your perfect squares, it's easier. If not, though, you can just sort of work your way down the line. So I'm going to do 45 to me is either 5 times something, but 5 is not a perfect square, and I can't do a lot with it, so I wouldn't necessarily start there always. But in this case, it is 5 times 9. And the square root of 5 is not going to get better. There's not a square root of 5. So that one's probably just going to stick. So usually for me, when I do this, I sort of circle what's going to stick. And then the square root of 9 is 3. I can't do any more roots to a number 3. So it's 3 square roots of 5. All right, quadratic formula. So negative b plus or minus the square root b squared minus 4ac all over 2a. And there is a really highly obnoxious song on YouTube if you know that this formula is hard for you to remember. And when I say obnoxious, I mean brainworm, obnoxious. The kind you'll be singing when you're walking through the house, kind of obnoxious. But it is great because it helps you memorize the formula in the event you should ever need it in the future. This guy is tricky a little bit because the equal marks is here, and this quadratic needs to be in standard form. So that would be one of the places that students mess up. So you want to subtract 2 from both sides. So we're actually plugging in 6n squared plus 11n minus 2 for our a, b, and c. And that's ax squared plus bx minus c as far as looking for your a, b's, and c's. So a is 6 in this case, b is 11, and c is a -2. And you're just going to plug that into your formula. So negative and b is 11 plus or minus square root. So 11 squared is b. And then a is 6, so times 6. And c is -2, so times -2. All over 2 times 6. You can plug that in your calculator straight through if you want. Be careful, because if you're not using the fraction option in a TI-83 or 84 or parentheses appropriately in Desmos, it'll be a communication issue between you and your calculator. Not that you don't know what you're doing. It's the calculator doesn't know what you're asking it to do. Or it'll read it in the wrong order, and that's where you can come up with some mixed up answers. I'm a huge fan of breaking it down so I know that me and my calculator are talking appropriately and together, but not everybody's going to do that, and it's not necessary. So 11 squared is 121. So I'm just going to take the part underneath the root bar. So 121 minus 4 times 6 is going to be 24, and then times a -2 So it's a negative and a negative, so it actually is going to become a positive. Negative, positive, negative, because that's going to be a negative 24 or minus 24. Times the negative 2 is going to be a positive 48. So that's going to go, and 121 plus 48 is 169. All over 12. And the square root of 169 is 13. So it's going to be a negative 11. Ooh, what did I do wrong? No, I didn't. Never mind. I'm good. Negative 11 plus 13 over 12. Negative 11 minus 13 over 12. So that's going to give us 2 over 12, which is 1.6 repeating, which looks like it should be this answer, ideally. And then negative 24 over 12 does give us that negative 2. So our answer would be, in this case, the third one, or C, depending on how you're looking at that bad boy. All right. So solve for x. Hopefully you realize in this one that there's not the bx, like ax squared plus bx. There's not a bx. There's only x squared and then constants. So if I subtract 2 from both sides, that's going to give me x squared equals 100. And then every time you square root something, because we're going to undo squaring, so the inverse operation of squaring is rooting. So we're going to take the square root of both sides. And every single time you take a root, even back when you did distance in Math 1, all the things that you've ever taken square root before, there are always 2 answers. But like in distance, the only answer that really matters is, obviously you can't, even walking backwards, you are covering a positive distance. So the negative never really actually mattered to the conversation. So I know some students didn't realize because they just kind of jumped over it. But every time you take a root, you have 2 answers. And you can write plus or minus 10, or you can write it as a list, negative 10, positive 10. Either way, if you do write it as a list, though, you want to use the squiggle parentheses. In this case, make sure you're paying attention as well. It says the positive solution. So though there are 2 answers, like this is basically a perfect example of like when you did distance formula, they're not worried about the negative one. They're only worried about the positive one. So your answer is a positive 10. Alrighty, number 6, so solving for the roots. So that's solving the quadratic. And this one didn't tell you how you had to do it. But again, there's not a x by itself. There's just the x squared. So I would add 9. So x squared equals a negative 1. Inverse operation of squaring is taking the root. And every time you take a root, you get a positive and a negative choice. So x equals positive I and negative I, or plus minus I, or again as a list. And that's just depending on the style of question. And the reason I'm pointing that out is in my Math 3 classes is where I really realized it on campus. If your answer choices aren't in the format that your teacher prior or your teacher at the moment is showing you, a bunch of people shut down. So there are lots of options. So when I share options, it's not to make it more complicated. It's to keep you from panicking when they write it slightly different and show you that it is the same thing. All right. Number 7, solve by completing the square. All right. So we're going to do x squared minus 18. X. That plus 56, we need to move it to the other side. So I'm going to do blank equals a negative 56. And then I'm going to put a blank. And those blanks for me are just to make sure I'm staying committed to the problem and don't lose the attention. Because a lot of people will do everything right and forget that second blank, like to add it to the other side. And we have to remember every time you do anything to one side of an equation, you have to do it to the other side of the equation. Then we're going to take our b, divide by 2, and then we're going to square it. So negative 18 divided by 2 is going to be a negative 9. Square is going to be a positive 81. So 81, 81. And then we're going to have to factor this. I'm pretty sure at least one of the videos, but definitely in class, you can kind of cheat your system here. This is not mathematically sound, but if you don't want to go into the whole factoring of this, then there's your answer right there. Is that negative 9 before you squared it? So it's going to be x minus 9 squared, or x minus 9, x minus 9, if you want to write it twice, equals negative 56 and 81. It's 25. We need to get x by itself. So again, it's in parentheses with that squared up there. So we're going to take the root of both sides because that's the inverse of squaring. And I end up with x minus 9 equals 5. And then we're going to add 9 and get 14. Yep, look at my answer choices. Make sure we're good. We know that's that one. And the way you would get your 4 is plugging in through the equation. All right, the way you get to 4, sorry, my brain's not awake yet. When you take the square root of the 5, I did exactly what everybody says. When you take the square root of the 5, you have a positive 5 and a negative 5. So you're going to solve it again with your negative 5. And that, when I add 9, gives me my 4. Oop, off screen, sorry. All right, it's coming back to me now. Okay, so number 8, again, doing the same idea. So x squared plus 8x. And I know I'm going to need a blank. And I have a negative 10 here, so I'm going to add 43 to both sides. And so negative 10 plus 43, so give me 33. Then again, a blank. Take my b, which is 8, divide by 2, then squared. So 4 squared is 16. So I'm going to add 16, add 16. Sorry, 4 squared. And again, this is your cheat if you don't want to get into actually factoring and thinking that through. There's like a sort of jump method. So then x plus 4 squared equals 33 plus 16, which is going to give me 49. There's a square. So to inverse or undo squaring, you're going to root both sides. And every time you root, you have a positive and a negative out here. So if x plus 4 equals 7, and x plus 4 equals negative 7. Subtract 4 from both sides. X is going to be 3. Subtract 4, subtract 4. X is going to be a negative 11. All right. Ooh, typo in number 9. Hopefully nobody panicked. So both of these were supposed to be x squared. So factoring, and this is when a is 1. So hopefully not too big a deal. And as I said many times, I'm not trying to unteach anything that someone taught you before me. So if you've got factoring down, awesome. Kill it. If not, I like what I call big star. And that's where AC goes up here, then A times X. And in this case, A is 1, so it's not a super big deal. But when A is not 1, it works. So negative 14 is that 1 times negative 14. Negative 5, and then you can put 1x, 1x. So I'm looking for the numbers that multiply to give me 14, but add or subtract to give me 5. So 1 and 14, 2 and 7, and that's it. 1 and 14, if I add them, give me 15. If I subtract, it gives me 13. 2 and 7, if I add them, I get 9. If I subtract, I do get 5. So 2 and 7 are the one we're going to focus on. And then B, the guy in the middle, is negative. So the big one's going to be negative. And then so our answer, or our factored answer, is x minus 7, x plus 2. And those are the factors. So we're not done yet because it says solve. So from there, we're going to keep going. So x minus 7 equals 0. X plus 2 equals 0. Add 7. So x equals 7 minus 2. X equals negative 2. The question asks for the negative solution. So it's getting negative 2. Not a factor of x squared minus x minus 12. See if I can get them both to show. Yep. So again, you could do your whole star, or just think about you need things that multiply to give me 12 that will add or subtract to give me 1. So 1 and 12, 2 and 6, 3 and 4, and then the next number would be 6 again, so you're done. 1 and 12 is 13 or 11. 2 and 6 is 8 or 4. 3 and 4. So we're going to focus on this group here. 4 is going to be negative because the b value is negative. So it's going to be x minus 4, x plus 3. So x minus 4 is, x plus 3 is. So which is not a factor would be x plus 4. Solving for the roots. In this case, this is the factored form, which is beautiful. That means just set everything equal to 0. All right, so 2 cannot equal 0. I just do that out of habit to make sure I don't leave out in the event that was 2x in the front, because if it was 2x, then that matters, because then you could come up with a factor. I mean, you could come up with a 0 or a root or a solution or x-intercept, because those are all the same things. We're going to get we're going to get x by itself, so we're going to subtract 1 from both sides. So 2x equals a negative 1. That's 2 times x, so we're going to divide by 2. X equals a negative 1/2. Then again, we want x by itself, so we're going to add 5. And then x equals 5. So the only solutions we have is a positive 5 and a negative 1/2. So positive 5, negative 1/2. And then the rest of them are not solutions to this quadratic in factored form. 12, we're factoring again when a is not 1. Check for GCF first. Always check for GCF first. And then I'm going to do big star. So 6 times 14. Oh, that's not what I put that in. Is 84. And then I have 6x, 6x, and 5. I don't know if anyone has ever shown you, or if I showed you. Sorry, my memory is a little crooked. But to find the factors of 84, if you are in a calculator and go to your y equals and type in 84 divided by x. Ooh, where's my x? Then hit second graph. All your whole numbers in that list are your factors. So 1 and 84, 2 and 42, 3 and 28, 4 and 21. So we know we got to get a lot further down. 6 and 14, we're getting closer. 7 and 12 will give me 5, ideally. And then just check to see if you have another one before you get to 12, and you don't. So 7 and 12, and our b value was positive, so 7's going to be positive. No, I'm sorry. 7 is going to be negative. 12 is going to be positive, because since the b value is positive in the middle, speaking to b value, then the bigger factor is going to be positive. Now, 6 and 7, as I said before, this is not a fraction. I can't say it enough. It's not a fraction. We're just cheating the system and seeing if I can reduce it. You can't. So it's going to be 6x minus 7. It's one of my factors. And then if I look at that not fraction on this side, those will reduce, because 6 and 12. And that gives me 1 and 2. And the x is still hanging out with that 1. So your next factor is 1x plus 2. Then solve them, because we're looking for zeros, which again are the roots. X-intercepts are solutions. So 6x minus 7 equals 0. Add 7 to both sides. So 6x equals 7. Divide by 6 is 7 over 6, which is the form of the answer, so that's perfect. And I have a positive, so ultimately here, but let's go ahead and make sure the other one is right. So x plus 2 equals 0, minus 2 from both sides, so x equals a negative 2. So this is definitely our answer. Another solve for the roots. Again, there's not a b value. It's just a and a c, or an x squared and a constant. So x squared minus 81 equals 0. We're going to add 81 to both sides. x squared equals 81. As soon as you see x squared, you're going to take the root of both sides. And x equals plus or minus 9. Or like I said, negative 9, positive 9. So your answer is this one and this one. And again, roots are the same thing as solutions, zeros, x-intercepts. All of those words mean to do the exact same thing. You're just setting those factors equal to 0 or setting your equation equal to 0. So fill in the blank. So we're looking for this number. When they move that 8, your b value is 10. So 10 divided by 2 is 5, and we're going to square it. That's where they got the 25s from, add it to both sides. And in this case, it's going to be c, and like I said, here's your cheat, so it's 5. Or you factor the c squared plus 10c plus 25. Find out what you multiply together to get 25. That'll add or subtract to give you 10. Roots of quadratic function. This is Pythagorean theorem, which means there has to be a triangle, not what we're doing. Negative b over 2a is solving for the axis of symmetry. Oh, I'm not spelling it right, sorry. Axis of symmetry, 2 m's. Quadratic, and then your linear. This is just the form for a linear equation, your standard form. Or I'm sorry, slope-intercept form. So that's, again, not the right lesson, so it's definitely your quadratic formula here. The next one, we're just factoring. So we want to know, what do we multiply together to get 10? That will add or subtract to give me 7. 1 and 10, 2 and 5 are my choices. 2 and 5 will give me 7, so it's looking good there. So I have a 5 already. So 2 was the answer you're looking for. This one is x minus 4 squared, and we're trying to look for the x-intercept, solutions, roots, again, all those fun things. I'm just going to take this and set it equal to 0 as it is. But as it's squared, that basically means x minus 4 equals 0, x minus 4 equals 0. So you're really only solving it once in this case because you're only going to have one answer because they're going to give you the same answer. So add 4 because it's negative on both sides, x equals 4. And if you did the same thing on this side, you'll get x equals 4 again. And so your answer is positive 4. And there's no need to write it twice because positive 4 happens one time. Oh, it ran off. 9 and negative 5. Uh-oh. I think this is 25 and this is 45. So quadratic function standard form has zeros of 9 and negative 5. You could either factor all of these, or if your 0 is 9, that means you had x minus 9 as a factor. And if your 0 is negative 5, then your other factor is x plus 5. And you can multiply these together if you understand that these factors give you those zeros. And then you're going to do x times x, which is x squared, x times 5, 5x, negative 9 times x, negative 9x, negative 9 times 5, negative 45. Combine your like terms in the middle, so clean up, as I like to say. So x squared, positive 5 and a negative 9 is going to give you a negative 4x, and then minus 45. So it should be B, this one. All right, everybody loves error analysis. So as I've told you before, sometimes it's hard to find a mistake in work, and it's easier just to work it yourself and then compare your work to someone else's. Totally up to you which way you do it. They definitely needed to put this back in standard form, so they moved the 1. It was positive, it became negative, so we're good there. And that means A is 4, B is 3, and C is negative 1. Should be negative B, which is good, plus or minus the square root, B squared minus 4 times A times C. So here would be one of our first mistakes. Make sure that's the only mistake. And then 2 times A, so we're good. So that negative 1, they just grabbed it. Though they showed moving it, it looks like they used their original positive 1 in that quadratic. And it would have made a difference because this would have become 9 plus 16 instead of 9 minus 16. So it would be the negative 3 plus or minus the square root of 25 all over 8. And that's negative 3 plus 5 over 8, negative 3 minus 5 over 8, just 2 over 8. So our answer would be 1/4 because you always want to reduce your fractions. And then negative 3 minus 5 is negative 8 over 8, so it should be negative 1. So it should be 1/4 and negative 1. Last but not least, we're only 2 minutes over, not too shabby. So solve round your answer. This is their work. What did they mess up? So we subtracted 54, perfect. Divided by 6, good. And then take the square root. You can't take the square root, or I shouldn't say it. You can't just come out with a whole number when you take the square root. That negative is a problem. So their first mistake would be somewhere, depending on what line you want to call that. Negative 9, though, would become the square root of 9 with an I. So the square root of 9 is a plus or minus 3i, which again can also be written as negative 3i, positive 3i in a list form. Alrighty, that was the quiz, guys.